Hey, how many of you here are software developers? Raise your hand. Okay. This will be tough because we'll talk about software and developing it. So what we basically do is we work on the layer, we work with a different robot, but it's a similar concept. This is a remote controlled drone, and we'll tell you more about it. And we're at the layer of the APIs, where other people take a product like this and kind of do fun things with it. And what we do is, for fun, is programming, so we program with it. As introduced by Holger, my name is Felix Geisendörfer. I'm at Felix G on Twitter. I run a little startup here in Berlin. We do file uploads and video encoding. And I'm also a contributor to this thing here, Node.js. I helped with making this initially. Was one of the first contributors. And
yeah, I'm Robin Mehner, on Twitter. Oh, there's the mic. Oh, sorry, I thought there's one. Okay, I run a small agency in Berlin called Robin. It's not easy. It's easy, and I'm mostly known for Berlin.js because I helped organize that, and I'm doing a conference, and basically I'm a user group. I'm doing a lot of community events, and yeah, in Berlin and everywhere, and yeah, that's your part. Again.
Yeah, and so what this NodeCopter thing is, it basically started as an event for programming flying robots with JavaScript. But that's no longer true anymore. We're basically working with any technology at this place, so people who can program in Ruby, in Python, in Java, or Go, or whatever, they can join our community and do fun things with that. So
yeah, what is NodeCopter? NodeCopter is actually, it's a full event programming flying robots, so it's everywhere these days, and it's also a community in the internet. So we have a website, and we are on Twitter and everything. And since we started, we have a lot of people involved and helping us out, writing modules for us and everything. And yeah, it originally started as a pre-event to JSConf.eu, which is also organized by Holger, and which is an awesome conference, by the way. And yeah, we started last year, back in October 2012. And our main idea was basically what will happen when we have an old swinging bass and a lot of drones, and we combined that. Yeah, it turns out it's a super fun event with a lot of hackers, hacking drones and having fun, doing awesome stuff, and yeah, occupying that old swinging bass with awesome stuff. So we had some guy who's actually has done object tracking with the drone. He had some small green dot on an iPad, and the drone followed the dot around through the whole swing hole, and we had even face detection, so this drone was able to follow faces. That's why the guy has the helmet on, because it's a bit unsafe. And we also had a drone matador, so this drone was able to recognize a red flag and actually attacked it. I don't know why this guy doesn't wear a helmet. He should have. So yeah, it was an amazing event back in the days, and yeah, these are all the people that have been there, and we had a lot of visitors too, and it was a really, really great event. And actually we thought, okay, that's the end. We were super exhausted, and everyone was super hyped too. But it turns out it really struck a nerve. So since then we had like at least 12 events everywhere. So we had events in Dublin, in San Francisco, in Zurich, in London, Bath, and basically everywhere. And I think there are even some missing. So yeah, and what's the drone we're talking about? That's your part.
All right. So I'd like to talk a little bit about this drone, and instead of just talking about it, I want to show you how it works, how you can operate with it, which means things can go wrong. So for the safety of the people in the first row, Robin, can you make sure nobody gets killed?
Yeah.
Thanks.
I might shoot at you.
His aim is not very good, so. So let's go to my code, and I'll make that font size right in a second. So the people in the back row, can you see this by now? This is good? Okay, cool. Basically, what's cool about this drone is that it's controlled via Wi-Fi, so I can just select it from my Wi-Fi networks here, and it should be able to log in. It's the joys of Wi-Fi. Come on. Okay, we're connected now. And what's kind of cool about this drone is it's literally another full computer running on there. It runs Linux, so you can actually telnet into this drone, and you're on a Linux computer. So if you've ever been on a Linux computer, Linux computer with a lot of delay right now, you can do these things. You can check out what processes are running on here. So for example, this program right here is the firmware itself, and you can literally kill it and replace it with something you wrote yourself for fun, which is what we do. It's not done yet, but will be eventually. So how would you go about telling this drone what to do? What the manufacturer wants you to do is they want to use the iPhone and create these apps, like pretty much similar stuff that Sphero has done, but I think your stuff looks much cooler than the Parrot stuff. Anyway, we don't do any of this. We want to make our computer programs tell the drone what to do, and at some point maybe even do intelligent things and kind of interact with the environment. We probably won't have, there's not enough time to do all of that, but let's get started with something simple. Let's just call that file fly.sh. What's cool about this demo right here is you could do this on any computer. If you buy a Mac off the shelf and you open up the terminal on it, if you type in the same keys, it will work right away. You need no other software. This is just bash. It's on the system. So what you can do here, you can type in these cryptically looking comments, def udp 192.168.1.1, and then you can give it a port. So this is for those who care a little bit. This is IP address of the drone. This is a port where it receives comments on. We're binding to UDP. It's a file descriptor we're creating. And then we type in more cryptic comments. Do a backslash here. No, that's wrong. And we do this. OK, and so basically this is one message being sent from my computer to the drone. And the message literally is just this text string, AT*ref equals 1, 512. So 1 is the sequence number in this case, and 512 is the random number that was chosen to make it take off. It's a binary representation, actually. So anyway, let's see if the demo gods are good with me today. We have one problem, so we've only programmed takeoff. There's no landing yet. So we'll see what we do about that. Seems to work. And that is the kill switch. If you're ever being attacked by a drone, you can try this. If it doesn't work, it's probably a different model. But it's something you can try. So that was very cryptic looking, and I only showed it because it shows how little you need to type into the computer to kind of make these things happen. But you probably want to use a real programming language for this when you do more with it. So one programming language that we've done a lot of stuff with is JavaScript, and here's kind of how it would look like in JavaScript. I would say I would create a little client object here. I would use a library that's already on the system, and I would say create client. And then I would say client.takeoff. And this is font, come on. This is still programming, but I think it's much more easy to understand than what I've just done before. It's kind of has some natural words in there and it's readable. So if we're lucky, we should be able to execute that as well. Come on. Oh, that's not good. That's what happens when you do live things. What? Has somebody found out that there's no password on the Wi-Fi? That was working a second ago. I'll skip to the next one. We're going to use yet another programming language. What could go wrong? We're going to use Google's Go programming language. And what we're going to do is we're going to make the drone do a little performance. So we're going to do this function main, and then we're going to import stuff from GitHub, and that's another module. And so what we're going to do here is we're also going to create a client by saying drone connect drone.default config, and then we check if there was an error. What do we do with an error? We panic. Then we just start doing stuff. So the first thing we could do is a takeoff, and then we could tell the drone to fly vertically. Now we need the time to tell it how long to do this for. So we would say for 1 time.second, fly up with half speed. So this argument would be between -1 and 1, depending on if you want to fly up and down and how fast. Then we want to do that for 1 second, 1.5. Then we want to give it a little time to stabilize. I mean, theoretically, we should be able to do the next thing right away, but what? Oh, thanks. So the reason we sleep here is because when the drone tries to stop, it actually has to stabilize a little bit first because it's physics and it's hard and it has to kind of do all these things it needs to do. Then the next thing we want to do is we want to roll. Not roll over yet, but just tilt to the left or right. Let's also do that for 1 second. Let's do that with half speed. Then let's do another sleep. Then let's add this. Basically what we're doing here is we make it fly to the right. I think right could also be left, it's kind of cryptic. And then hopefully go to the left again and come back to us. I'm not deleting my code. So, and now, because nothing could go wrong with this, we're going to try a little animation. And so one of the things the drone can do is a flip. Let's see, it should do that. And then we have time.sleep. We're going to do that for, 5 seconds. And then we're going to do client.land. All right. Say what? Now we can try it out and see if it runs. Oh, Wi-Fi. The demo gods are not good today for sure. At least it's telling us it's not working. That's a very sad thing. Let's debug for a second. We're still doing well in time. So we can ping the drone, so the networking is there in general. We can telnet into it. There's really no good. If somebody had actually connected to the Wi-Fi before, it may be interfering because there's a second client connected now, and I cannot control it. So what we're going to do is we're going to turn off the battery and turn it back on. And then please don't log in again. This is what real software development actually looks like. Nothing works the first time. Yeah. They have a mind of their own, these things. Okay. Okay, we're connected again. All right. It's a new error message. We've made progress. We did make progress. Now we're back to the old error message. It's not so much progress. Interesting. All right. Uh-oh. That was not supposed to happen. Nice. So this is kind of what we do for fun, and it is a lot of fun. So even if you're not a software developer, but maybe interested in dabbling with programming, the drones are fun. Anyway, we've got some few other things to show, and let's see if the demo gods are not good today. But so the people at the events, the NodeCopter events we've been organizing, have been hacking on all kinds of interesting things, and I'll just show you two. So one is called the NodeCopter monitor here, and what this thing basically does is it takes the sensor information that the drone sends, and it streams it to a browser, and then it uses WebGL in the browser to actually create a 3D model of the drone and render this. And, well, as I said, the demo gods are not very good today, but when there's no Wi-Fi interference, it will actually do very smooth updates of this.
There's no Wi-Fi.
Well, and if the Wi-Fi is connected. Wow. Wait, how does it, what? Okay. Magic technology. All right, so it's working again, is it? Yeah. All right, so this is kind of fun. People, they've never done that before. They've never done WebGL 3D stuff in the web browser, but they were like, oh, I have this drone to play with and I need to do fun things. So they came up with this and learned all the stuff they had to do this. Another really fun project is this one right here, NodeCopter monitor. What? Oh, thanks. So Node drone stream. And I'll show you what this does. I will not let the bad demo gods win this one. So, all right. Localhost 4040. And so what this thing basically does, it streams the video image from the drone, and hopefully we'll get lucky and catch a few good seconds. The Wi-Fi here was working really well for using it on the computers. That makes it work bad on the drone because it's also Wi-Fi based. Okay, now it's kind of working. So when it's kind of working, what's nice about this demo is it's actually doing two cool things. One cool thing is it takes the video stream from the drone, which is H.264, and because that is a pure video stream, it has no container format around it, it actually has to decode the H.264. And the web browser APIs can't let you do it. So it's actually doing the H.264 decoding in pure JavaScript, which the people at Mozilla, they've created a project called Broadway.js, which makes that possible. And Bernhard Weisshund, who did this demo, figured out how to take Broadway.js and hook in a data stream rather than make it work with a file. And there was a lot of work in here to dive into a lot of protocol stuff. This is more fun when the camera image is steady. Maybe closer to the Wi-Fi, further. I should have recorded this part. Are we getting lucky? Yes, we are. Okay, I'll have to use this, and I'll just do it. So what you're seeing right now is basically a computer vision algorithm called Optical Flow, and it's not perfect, and there's a collateral damage joke somewhere in here, but what it does is it tries to track one point in an image and then keep tracking it as the image moves around. And this is also something that's done in pure JavaScript, and Bernhard, who did this, had never played with computer vision stuff before, and he just picked it up and was like, hey, this is really fun. Now choosing a crosshair is a little questionable given the drones. But other than that, it's kind of a very fun demo. And I think that concludes the demo part, which brings us to why would you want to do this?
Yeah, but it's still your part.
Oh, it's still my part. So survival is the first part. Because whether you like it or not, these drones are used for both good and evil. And in the future, I think there will be a lot of these flying over our heads, not just these, but drones in general. And just having an idea of how these drones operate, what they're capable of, what the software layer looks like, I think it's a good skill to have in the future. And even just for things for, when it comes to privacy, when people use these drones to spy on you, you kind of want to know is how do they send the data back, how can you block this communication from happening. So I think that's one good reason. And now it's Robin's turn.
The other good reasons are basically, I mean, it's a good toy to learn new programming languages. I mean, you have seen Felix using Bash, then trying to use JavaScript, and afterwards using Go just to hack this kind of thing. So it's a good thing to just learn a new programming language. And you can play around with a lot of technologies like WebGL, WebSockets, or H.264, or even computer vision and OpenCV. I mean, I got a project through NodeCopter for an OpenCV client project, which is really super nice. And I've never done it before if it wasn't for NodeCopter. And you can learn about UDP networking, accelerometers, PID controllers, and even more advanced stuff like Kalman filters, which is a thing we are working on for the firmware right now, and it's really, really crazy. So if anyone is good in Mars, approach us, please. We need help. And yeah, you can also, I mean, all the stuff we've done has been done by reverse engineering the protocol and everything. We have some documentation which is okay, but has some bugs, so there's a lot reverse engineering involved. And also another great part for us, and one of the main motivations for us is it's super easy to get started. I mean, you don't need any electronic skills, you don't need any soldering, you don't need to know anything about how about cable wiring, all this stuff, and it's super easy and great to learning programming. I mean, I started with 12 to starting to program robots, and that's the thing we saw too. I mean, we brought this copters to kids, and they started immediately because it's like 2 lines of code, and these things fly against the wall, but these fly. So that's super good, and it's one major motivation for us to get started and go on. And that's the main reason we put on our website. It's NodeCopter.com, and everything we do is open source. The whole website is open source. There are guides on it. There are FAQs on it. And if you want to organize an event, there's a compass that helps you to organize these events and all this kind of stuff. So we try to build a platform that you can use as educational platform for kids, or even as students, or even if you're just new to this thing, because it's super easy to get started and you don't need much. Just a drone, and if you ask nicely, you can lend someone from us, and then just start. It's super easy, and the results are very fast. So, and I think Felix has got something special for you.
Yeah, so one thing that is a problem is that organizing these events where people come together and program these drones, it's kind of expensive because you need to buy a lot of these drones, and there's no money-making scheme here. We're just doing this for fun. So we've been thinking about how could we help a lot of people who want to organize these events, who want to do them in their city, who want to have fun with this, without all of them having to go out and kind of make separate people rich. So what we've come up with is this. Oh, no slide. Can I get... Oh, okay, here's the slide. This is called the Summer of Drones, which is something we're organizing. And the basic idea is that we want to kind of pool together sponsorship money from different companies and use that to buy 80 drones. And we want to kind of split them up into 4 sets of 20 drones each and ship 2 of these sets to Europe, 2 to they ship from Europe, but 2 to North America. And then we send them from event to event. The events are always happening on Saturdays, and all the event organizers really have to do is find a venue, get the people in to do it, and pay for the shipping from one place to another. But they don't need to go out and buy all these quadcopters. And this is going to happen from June throughout to September 2013. If all works according to plan, we should have up to 34 events. I think by now we have over 25 organizers who are taking part in this, and we may see up to 1,500 developers at these events total. And yeah, what's next? Your city. We're still looking for a few organizers who want to bring these events to cities in especially Europe. I think US is mostly filled up, but if you're from another city and you're like, we need to have this, get in touch. Yeah, it's all on summerofdrones.com. We're also still looking for a few awesome companies to help us sponsor it, and I think that's pretty much all we got right now. Thank you.
Thank you.
Any questions to these 2 guys?
Don't be shy.
There's a question.
Why are you focusing on the parrots and not some Bobby King factory?
So I was in a program called First Robotics, and one of my previous mentor turned me on to these drones. He was like, do you know about these drones? I was like, yeah. He was like, do you know that you can program them? I was like, no, that's interesting. So I just went and bought one, and it kind of just, because I had this drone, I started programming it. Then we started doing this event, and it kind of just happened. We didn't like go out and see what's the best drone or robot to use. Yeah. But I should add one thing, sorry. We're not like perfectly happy with them. They're like the firmware and some stuff is proprietary, and the manufacturer is a little difficult to work with. I mean, I would imagine a company to be very forthcoming and help us. I mean, they are helping us, but they're like, we want people to write mobile apps. And so if you have other robots that are fun, tell us about them. There's a question.
How many of the drones have you rigged so far, and how many have crashed?
Go ahead.
Not that much, actually. I mean, we had, like, as I said, 15 events, 20 events, something around that, and we didn't have a total crash. I mean, the worst thing that can happen is that the central cross breaks, and that's in repair for like an hour, and the repair part costs you $25. So it's really cheap, and they're super easy to repair, and there are tutorial videos on how to repair them everywhere. I mean, but you need an Amazon Prime subscription because you basically, ordering repair parts all the time.
And in terms of breaking them with the software, none. We've not done stuff that would do this. It would only happen if we screwed with the Linux settings on the machine and killed the networking or something. And we didn't have that happen yet because we were smart enough to not touch it. Yeah.
I have two questions. So first question is, if you use those in public, are there any limitations? Like, for example, if you use that for advertising campaign, you go through cities and you have planners connected to the device. So is that illegal, or is there any like that you, if you make it in public, is it legal or not?
I'm not a lawyer, but as far as I know, in Germany there's a regulation that drones have to be operated within eyesight, so you have to have eye contact with them at all times. There's probably other regulations that apply as well, but I wouldn't know all of them.
And a strong limitation is battery life.
Yes.
It's like 15 minutes. So.
Yeah. But if you have people switching batteries all the time, it's not a problem.
An Überraschungsei, as you call it, that might work. We had a sandwich copter in Brighton, so it was able to deliver sandwiches to other attendees, but I think it doesn't get higher than this. I mean, it's like maybe 100 to 200 gram, but nothing more. Yeah, that might work.
Yeah, that would work.